Imagine you are working in a company around 15 years ago. The company has one small server room. There are physical servers, cables everywhere, UPS systems, cooling systems, racks, and one system administrator sitting nearby monitoring everything. Now imagine one day the company suddenly grows. More customers start using the application. The server becomes slow. Storage becomes full. Users complain the website is not loading. Suddenly management asks the IT team, "Can we increase performance quickly?" Now the real problem starts. The infrastructure team has to purchase new hardware. Procurement takes time. Delivery takes time. Installation takes time. Rack setup takes time. Network configuration takes time. Sometimes it may take weeks or even months. This was the traditional on-premises infrastructure model. Now cloud computing changed everything. Instead of buying physical servers, companies can create virtual servers within minutes using AWS. Need storage? Create storage instantly. Need backup? Configure backup instantly. Need additional servers? Scale automatically. Need disaster recovery? Replicate infrastructure across regions. This flexibility is the reason companies moved heavily towards cloud. Now think about modern applications like Amazon, Netflix, Swiggy, Zomato, banking applications, online education platforms. Millions of users are accessing these applications continuously. To support this huge traffic, companies need scalability, high availability, security, monitoring, disaster recovery, cost optimization. This is where cloud architecture comes into the picture. Cloud architecture is basically designing infrastructure properly so applications run securely, efficiently, and reliably. As cloud engineers, our responsibility is not only creating servers. We must understand how users access applications, how traffic flows, how security works, how backups happen, how scaling happens, how to reduce downtime, how to optimize cost. This is the real meaning of cloud engineering. And one important thing. Many freshers learn AWS services by memorizing definitions. But experienced professionals think differently. They ask, why are we using this service? When should we use it? What business problem does it solve? That thinking is what makes someone a real cloud engineer. In this entire session, we are not learning only AWS services. We are learning how real-world infrastructure works in production environments. Understanding VPC. Now let us imagine a company is starting a new online shopping application. Before deploying servers, databases, or applications, the first thing engineers think about is networking. Because everything in cloud runs inside a network. In AWS, this private network is called VPC. VPC means Virtual Private Cloud. Think of VPC like a company office building. Inside the building, there are multiple rooms, security restrictions, different departments, internal communication, controlled access. Similarly, inside AWS VPC, servers communicate, applications communicate, databases communicate, security rules are applied, traffic is controlled. Now imagine if there was no VPC. Every server would directly communicate publicly. That would create massive security risks. So companies first create a VPC to isolate their infrastructure. Now inside the VPC, engineers decide which resources should be public, which resources should be private, which applications need internet, which systems should remain internal. For example, web servers may be public. Databases should remain private. This separation is very important. Now another important thing. A cloud engineer must not only know how to create a VPC. They must understand why VPC is needed, how traffic flows, how security works, how routing works, how internet access works. In interviews, companies do not care if you memorized. VPC is a logically isolated network. They care whether you understand real infrastructure design. Because in production environments, Networking mistakes can cause outages, create security breaches, increase cost, break applications. That is why VPC is one of the most important AWS concepts. Whenever a project starts in AWS, one of the first tasks is designing the network architecture properly. Public and private subnets. Now let us continue the company application example. Suppose the company has customers accessing a website, internal application servers, database servers storing customer information. Should all these servers be exposed directly to the internet? Absolutely not. This is where public and private subnets become important. Think of a shopping mall. Customers can enter public areas, but staff rooms, cash rooms, and management rooms are restricted. Similarly, in AWS, public subnet is accessible from internet. Private subnet is restricted and internal. Now let us understand the real-world flow. When customers open a website, customer internet public infrastructure. Because customers must access the application publicly. So resources like load balancers, web servers, may be placed in public subnet, but back-end systems like application servers, database servers, should remain in private subnet. Why? Because databases contain sensitive information. Imagine exposing banking databases directly to internet. That would be dangerous. So architects design infrastructure carefully. Now another important thing. Private servers still need internet sometimes. For example, Windows updates, Linux patching, antivirus updates, package downloads. But we still do not want the internet accessing those private servers directly. This is where NAT Gateway helps. One important interview understanding. When interviewers ask, why private subnet? Do not simply say, for security. Explain practically. Say, back-end application and database servers contain sensitive internal communication and should not be directly exposed to the internet. That sounds professional and production-oriented. This is how real cloud engineers think. Internet Gateway and NAT Gateway. Now let us understand how internet communication actually works inside AWS. Imagine you deployed a web server in AWS. Customers are trying to access your website from internet. But there must be some connection between your AWS network and the internet. That connection is called Internet Gateway. Internet Gateway connects your VPC to the internet. Without Internet Gateway, public servers cannot access internet. Customers cannot access your website. Now let us see the flow. Customer internet, Internet Gateway, public subnet, web server. This is how customer requests enter the AWS environment. Now let us think about private servers. Suppose application servers are in private subnet. We do not want them publicly accessible. But they still require outbound internet access for dates, patching, software installation. This is where NAT Gateway comes into the picture. NAT Gateway allows private servers to go out to the internet securely. But internet users cannot directly come in. This is very important. Now let us think like cloud engineers. If an engineer accidentally places a database in public subnet, huge security risks may happen. Data leakage may happen. Compliance issues may happen. That is why networking architecture is very important. Real cloud engineers always think, which systems should be public? Which systems should remain private? How traffic flows? How security is maintained? This thinking is more important than memorizing AWS definitions. Load balancer and high availability. Now let us imagine a real production situation. Suppose your company has an e-commerce website. Suddenly, during a festival sale, thousands of users open the application. Traffic increases heavily. One server becomes overloaded. What happens if only one server exists? The application may crash. Website becomes unavailable. Customers complain. Business loses revenue. This is why companies use multiple servers. Now another problem. How do we distribute traffic between multiple servers? This is where load balancer comes into the picture. Load balancer distributes traffic across multiple servers. Instead of all users hitting one server, traffic gets balanced. Now another important concept. What happens if one server fails? Should the application go down? Well, this concept is called high availability. Applications should continue working even if one server fails. This is achieved using multiple servers, multiple availability zones, load balancers, auto-scaling. Now think practically. If one data center faces issues, another availability zone continues serving traffic. This is why cloud applications are more reliable than traditional small infrastructures. In interviews, companies love scenario-based thinking. For example, how would you prevent application downtime? Good answers include load balancer, multiple availability zones, auto-scaling, backup infrastructure. This shows production-level thinking. Imagine this. You are working as a cloud engineer in a startup company called ShopEasy. The company has a website, customer database, payment application, and around 50 employees. One day, the CEO calls the IT team and says, "Our business is growing fast. We are moving everything to AWS. But I don't want hackers, data leaks, or downtime. Secure everything." Now your responsibility as a cloud engineer starts. 1. IAM users and roles. So first, what is the biggest mistake companies do? They share one AWS root account password with everyone. Imagine 10 employees using the same login. If something goes wrong, nobody knows who deleted the server or changed settings. That is dangerous. So in AWS, we create IAM users. For example, Mahesh Cloud Engineer, Ravi Developer, Priya Tester. Each person gets their own username and password. Now comes IAM roles. Suppose developers need temporary access to an S3 bucket or EC2 server. Instead of sharing passwords, AWS gives temporary permissions using roles. Real-time example. A developer launches an EC2 server that needs access to an S3 bucket for downloading application files. Instead of storing AWS keys inside the server, we attach an IAM role. This is secure because no hard-coded passwords, temporary permissions, easy auditing. This is how professional companies work in production environments. 2. Security groups. Now imagine your office building. Not everyone can enter every room. Security guards check who can enter, which floor they can access, which doors remain locked. In AWS, security groups work exactly like security guards. Example. Your company has web server, database server. Users from the internet should access only the website. But database servers must stay protected. So we configure port 80 and 443 open for web traffic. Database port 3306 allowed only from application servers. Real-time attack example. If port 22 SH is open to the whole internet, hackers continuously try brute force attacks. Security groups prevent this. That's why companies never allow unnecessary ports. 3. Least privilege principle. This is one of the most important security concepts in the cloud. Least privilege means give only the minimum permissions required. Real-time office example. A cleaning staff member does not need access to the finance locker room. Similarly, in AWS, developers don't need billing access. Testers don't need production delete permissions. Junior admins should not have full administrator rights. Imagine a new employee accidentally deletes production servers because they had full admin access. The company may lose lakhs of rupees in minutes. So instead of giving administrator access, we give read-only access, specific S3 permissions, EC2 restart permission only. This reduces human mistakes and insider threats. 4. MFA for accounts. Now imagine your ATM card. Even if someone steals your card, they still need the PIN. MFA works the same way. Password alone is not enough. AWS asks for password, OTP from mobile authenticator app. Real-time example. Suppose an employee's password gets leaked in phishing email attacks. Without MFA, hacker logs in immediately. With MFA, hacker still cannot access the account because OTP is required. That extra 30-second security layer can save the company from a major breach. Most companies make MFA mandatory for root account, admin users, production access. 5. Private subnet protection. Now let's talk about private and public areas. Imagine a shopping mall. Customers can enter reception, shopping area, but back-end rooms like cache storage, CCTV room, main server room are restricted. In AWS, public subnet equals internet accessible. Private subnet equals internal secure systems. Real-time architecture example. Front-end web server public subnet. Database server private subnet. Why? Because databases contain customer data, payment details, business records. They should never be directly exposed to the internet. Even if hackers compromise the web server, the database still remains protected inside the private subnet. 6. Encryption and backups. Now imagine losing your mobile phone. If the phone is encrypted, strangers cannot access your data. AWS encryption works similarly. We encrypt BS volumes, 3 buckets, databases, backup. So even if storage is stolen or accessed illegally, data remains unreadable. Now backups. Every experienced cloud engineer knows one thing. Failure is not a question of if. It is when. Real-time examples. Accidental deletion, ransomware attacks, database corruption, region failure. Suppose a developer accidentally deletes customer data. Without backup, business stops, huge financial loss. With backup, restore within minutes. That is why companies use automated snapshots, cross-region backups, AWS backup services. 7. Monitoring security events. Finally, security is not set and forget. You must continuously monitor everything. AWS provides services like CloudWatch, CloudTrail, GuardDuty. Imagine this real-time scenario. At 2 a.m., someone tries 500 failed login attempts from another country. AWS monitoring tools immediately detect unusual activity. The security team receives alerts. They can block IPs, disable compromised accounts, investigate logs. Without monitoring, attacks remain invisible. Professional cloud engineers always monitor login activity, permission changes, failed access attempts, network traffic, CPU spikes, unusual API calls. Because prevention is good, but fast detection is even more important. AWS monitoring and production support. Now imagine this. Your company's website is running successfully on AWS. Customers are placing orders. Employees are working. Applications are running smoothly. Everything looks perfect. But suddenly, at 11:30 p.m. during a big sale, customers start calling. Website is slow. Payment page is not loading. Application crashed. Now everybody looks at the cloud engineer and support team. This is where monitoring and production support become extremely important. 1. CloudWatch monitoring. So first question. How do we know what is happening inside servers in real time? That's where AWS CloudWatch comes into the picture. Think of CloudWatch like a hospital heart monitor. Doctors continuously monitor heartbeat, oxygen, blood pressure. Similarly, CloudWatch monitors CPU usage, memory, disk activity, network traffic, logs, server health. Real-time example. Suppose your e-commerce application suddenly receives 50,000 users during a festival sale. CloudWatch immediately shows CPU spike, High network traffic. Increased response time. Without monitoring, the team would not even know why the application is slowing down. CloudWatch gives visibility into everything happening inside AWS infrastructure. 2. CPU and memory alerts. Monitoring alone is not enough. The system should automatically alert engineers before servers crash. Imagine driving a car. Before fuel becomes empty, the dashboard gives a warning light. CloudWatch alarms work exactly like that. Real-time example. Your production EC2 server normally runs at 40% CPU. Suddenly CPU reaches 95%. This may happen because heavy traffic, bad application code, background process issue, possible attack. CloudWatch sends alerts through email, SMS, PagerDuty. Now the support engineer can react immediately. Another real-time situation. A Java application may consume all memory because of a memory leak. If RAM becomes full, application freezes. Users face downtime. But with memory alerts, team receives warning early. Server can be restarted or scaled. This prevents major outages. 3. Application log monitoring. Now imagine this. Customer says, I clicked payment button but money got deducted twice. How do engineers investigate this? By checking application logs. Logs are like CCTV footage for applications. Every activity gets recorded. Login attempts, errors, API calls, database failures, payment requests. Real-time example. Suppose developers release a new code update. After deployment, application starts throwing 500 internal server errors. CloudWatch logs immediately capture error messages, stack traces, failed API calls. Now support teams quickly identify which file failed, which service crashed, what caused the issue. Without logs, troubleshooting becomes blind guessing. 4. Detect downtime quickly. In production environments, every minute matters. Imagine an online food delivery company. If the application is down for 30 minutes, orders stop. Customers get angry. Revenue loss happens. So companies use monitoring tools to detect downtime immediately. Real-time example. Your website health check runs every 1 minute. If the website stops responding, CloudWatch detects failure. Alarm triggers instantly. Support team gets notification. Now engineers quickly restart services, replace failed server, shift traffic to healthy servers. The faster downtime is detected, the faster business recovers. 5. Performance analysis. Sometimes systems do not completely fail, but they become slow, and users hate slow applications. Real-time example. Suppose login page normally loads in 2 seconds, but today it takes 15 seconds. Customers start leaving the website. CloudWatch metrics help analyze CPU bottlenecks, disk latency, network delay, database performance. Engineers compare past performance, current traffic, resource utilization. This helps identify root cause. Maybe database queries are slow, application code is inefficient, server size is too small. Performance analysis helps companies improve user experience before customers complain. 6. Incident troubleshooting. Now let's enter real production support life. It is 2 a.m. Suddenly a P1 incident ticket comes. Production application unavailable. Now the support engineer must stay calm and troubleshoot step by step. Typical troubleshooting process. First check. Is EC2 server running? Is CPU overloaded? Are services active? Any disk full issue? Any application errors in logs? Real-time troubleshooting example. A website stopped working because disk space became 100% full. Why? Because application logs kept growing continuously. CloudWatch monitoring helped identify disk utilization spike, large log files. Support team cleaned logs and restarted services. Application recovered within minutes. This is real-world incident management. 7. Production support activities. Production support is not only fixing issues. It is about keeping systems stable 24/7. Daily activities include monitoring dashboards, checking alerts, reviewing logs, handling tickets, coordinating with developers, updating incident reports, performing health checks. Real-time support scenario. Suppose developers release a new application version. Support engineers monitor CPU usage, error rates, application response time, database connections. If any issue appears, rollback happens immediately. Production support teams are like emergency response teams for IT systems. Their goal is simple: keep business running without interruption. So in AWS environments, monitoring is not optional, because servers can fail, applications can crash, traffic can suddenly increase, hackers can attack, developers can make mistakes. A good cloud engineer always watches the environment proactively, because in real production, the best engineers are not the ones who only fix problems. They are the ones who detect and prevent problems before customers even notice them. AWS cost optimization. Imagine this. A startup company successfully moved its applications to AWS. Everything was working perfectly. Servers were running. Databases were active. Applications were available 24/7. But after 1 month, the finance manager walks into the IT room holding an AWS bill. And everyone becomes silent, because the bill is much higher than expected. Now the company asks the cloud engineer one important question. Why are we paying so much? And how can we reduce the cost? This is where AWS cost optimization becomes very important. 1. Pay only for usage. One of the biggest advantages of AWS is you pay only for what you use. Think about electricity at home. If lights are on all day, bill increases. If unnecessary devices are turned off, money is saved. AWS works exactly the same way. Real-time example. Suppose your company launches a temporary testing server for 1 week. In traditional data centers, you buy physical hardware. Huge upfront investment is required. But in AWS, start server when needed. Stop when work finishes. Pay only for usage hours. This flexibility helps startups save huge amounts of money. 2. Stop unused servers. Now imagine this real scenario. Developers create multiple EC2 servers for testing, demo environments, temporary projects. After project completion, they forget to stop those servers. But AWS billing continues every hour. Real-time example. Suppose 5 unused EC2 servers run continuously for 30 days. Even without users, CPU charges continue, storage charges continue, P charges may continue. This becomes unnecessary waste. Professional cloud engineers regularly check idle servers, unused environments, non-production systems. During nights or weekends, development servers can be stopped automatically. This simple activity alone can reduce AWS bills significantly. 3. Resize oversized EC2 instances. Sometimes companies use very large servers unnecessarily. Imagine buying a 50-seater bus to transport only 2 people daily. Waste of money, right? Same thing happens in AWS. Real-time example. An application server was launched with 16 CPU, 64 GB RAM. But monitoring shows actual usage is only 10% CPU, 15% memory. That means company is paying for resources it never uses. So engineers resize the instance. From large instance to medium or small instance. Performance remains same, but monthly cost drops heavily. This process is called right sizing. 4. Move old data to Glacier. Now think about old company files. Not every file needs fast access all the time. For example, old invoices, backup archives, previous year logs. These files are rarely used. Keeping them in high-speed storage becomes expensive. AWS provides Glacier storage for this purpose. Real-time example. Company stores 5 years of application logs, old backup files, compliance records. Instead of storing everything in expensive S3 standard storage, they move old files to Glacier. Benefits: very low storage cost, secure long-term storage, good for archival purposes. This saves thousands of rupees monthly in large environments. 5. Delete unused snapshots. Now imagine taking mobile backups every day, but never deleting old backups. Eventually storage becomes full. Same thing happens in AWS with snapshots. Snapshots are backups of EC2 volumes, databases, file systems. Real-time example. Every night automatic snapshots are created. After 1 year, hundreds of old snapshots remain. Many may no longer be needed, but AWS still charges for snapshot storage. Cloud engineers regularly review old snapshots, duplicate backups, expired retention backups. Unused snapshots are deleted carefully after verification. This reduces unnecessary storage cost. 6. Monitor AWS bills. One important habit of good cloud engineers is never wait until month-end to check billing. Real-time example. A developer accidentally launches a very expensive GPU instance. Within 2 days, AWS bill suddenly increases. Without monitoring, company notices only after month-end. But AWS billing alarms help detect abnormal spending early. Engineers configure alerts like notify if bill crosses 5,000 Indian rupees. Notify if daily spending spikes. Now teams immediately investigate. Which service increased cost? Which server caused billing spike? Whether resources are unused. Cost monitoring prevents financial surprises. 7. Use auto-scaling. Now let's see one of the smartest AWS features. Imagine a shopping mall during festival season. Normally, 5 counters are enough. But during huge crowds, more counters are opened automatically. AWS auto-scaling works similarly. Real-time example. An online shopping website receives normal traffic during weekdays, massive traffic during sales events. Without auto-scaling, company keeps many large servers running all the time. Huge waste during low traffic periods. With auto-scaling, new servers launch automatically during high traffic. Extra servers terminate during low traffic. Benefits: better performance, reduced downtime, lower cost. You use resources only when needed. So AWS is powerful. But without proper monitoring and optimization, cloud bills can grow very quickly. A smart cloud engineer always focuses on performance, availability, and cost control. Because companies do not just want systems running. They want systems running efficiently. Real-world cloud engineering is not only about launching servers. It is about balancing security, performance, reliability, cost optimization. That is what makes a professional AWS engineer valuable in production environments. Disaster recovery and business continuity in AWS. Imagine this. It is Monday morning. Employees are drinking coffee. Customers are placing online orders. Everything is running smoothly. Suddenly, the company website goes down. Nobody can log in. Payments stop working. Customer support phones start ringing continuously. CEO rushes into the IT room and asks, "What happened?" Cloud engineers quickly discover the problem. Production database failed. Now here comes the most important question. Do we have backup and recovery? This is where disaster recovery becomes a hero. 1. Snapshots and backups. Think of backups like saving game progress in a video game. If your game crashes, you can continue from the last saved point. AWS backups work exactly the same way. Real-time example. Suppose a developer accidentally deletes important customer records. Without backup, data may be lost forever. Business panic starts. But with AWS snapshots and backups, engineers restore data quickly. Customers barely notice the issue. Snapshots are basically copies of servers, copies of disks, copies of databases. Companies schedule backups daily or hourly depending on business needs. Because in production, mistakes happen all the time. 2. Multi-region strategies. Now imagine this funny situation. Your entire office exists in only one building. Suddenly, flood comes, or power failure happens, or internet goes down. Entire business stops. That's risky. AWS solves this using multiple regions. Real-time example. Primary application runs in Mumbai region. Backup infrastructure exists in Singapore region. If one region faces problems, traffic can shift to another region. This is called multi-region strategy. Big companies like Netflix, Amazon, banking applications use multiple regions for high availability because businesses cannot depend on only one location. 3. Restore procedures. Now having backup alone is not enough. Imagine owning a fire extinguisher, but nobody knows how to use it during fire. Same problem happens in IT. Companies must know how to restore servers, how to recover databases, how long recovery takes. Real-time example. A ransomware attack encrypts production data. Support team follows restore procedure. Stop affected systems. Identify latest healthy backup. Restore database. Validate applications. Bring services online. Because procedures are already documented, recovery becomes faster and less stressful. Professional teams regularly test recovery drills. 4. Protect business data. Now think about what is most valuable for companies today. Not furniture, not office walls. It is data, customer information, payment records, orders, business reports. Everything depends on data. Real-time example. Suppose an online shopping company loses customer orders, payment history, inventory details. The business may completely stop. So AWS helps protect data using encryption, replication, automated backups, access controls. Cloud engineers treat business data like treasure, because once important data is lost, trust is also lost. 5. Recovery after failure. Now let's talk about real-world failures. Failures can happen because of human mistakes, hardware crashes, cyber attacks, application bugs, natural disasters. No company can avoid every failure, but smart companies prepare for recovery. Real-time example. An application deployment goes wrong. New code crashes production servers. Immediately engineers roll back deployment, restore previous version, recover services. Within minutes application becomes stable again. The goal is not never fail. The goal is recover quickly when failure happens. 6. Reduce downtime. In production support, every minute of downtime costs money. Imagine airline booking system down, food delivery app unavailable, banking application stopped. Customers become frustrated immediately. Real-time example. A company's website generates 5 Indian rupees lakh sales every hour. If website remains down for 3 hours, huge financial loss happens. So disaster recovery focuses on faster restoration, quick failover, automated recovery. AWS services like auto-scaling, load balancers, multi-Z deployments help reduce downtime significantly. 7. Business continuity. Now this is the final goal of disaster recovery. Business continuity means keep business running even during problems. Imagine a hospital system. Even during server failures, power issues, network outages, patient systems must continue working. Real-time example. An online banking application cannot simply say, "Server down, come tomorrow." Business must continue 24/7. So companies prepare backup plans, recovery teams, alternate regions, emergency contacts, failover systems. This ensures customers continue receiving services even during unexpected situations. So finally, disaster recovery is like having spare tire in a car, power backup at home, insurance for business. You hope you never need it. But when disaster happens, it becomes the most important thing. A good cloud engineer is not someone who says, "Failures will never happen." A real professional says, "Even if failure happens, we are fully prepared." Because in real production environments, servers may fail, applications may crash, humans may make mistakes, but businesses must continue running. AWS career path and interview preparation. Imagine this. One student starts learning AWS. First day. He opens AWS console and suddenly sees C2, 3, VPC, CloudWatch, Lambda, Route 53, and immediately says, "Why are there so many services?" Don't worry. Every experienced cloud engineer once felt exactly the same. Nobody becomes a cloud architect in one day. AWS career growth happens step by step. Just like leveling up in a game. 1. Support/admin role. Every AWS journey usually starts here. This is where engineers learn monitoring, ticket handling, basic troubleshooting, user management, server health checks. Real-time example. Imagine your company website suddenly becomes slow. As a support engineer, your first responsibility is check CPU usage, verify services, review logs, restart application if needed, escalate issues if required. This role teaches the most important skill in IT: how production environments actually work. Many beginners think cloud jobs mean only launching servers. But real companies need engineers who can handle incidents, stay calm under pressure, troubleshoot quickly. This stage builds strong foundation. 2. Cloud engineer role. Now, after gaining support experience, you slowly move into cloud engineer role. Here you start building infrastructure. Real-time tasks include launch EC2 servers, configure VPC, create IAM users, set up load balancers, configure auto-scaling, create S3 buckets. Now you are not only supporting systems, you are designing and deploying them. Real-time scenario. A company wants to move its application from physical servers to AWS. Cloud engineer responsibilities. Set up networking, configure security groups, create backup plans, monitor infrastructure, ensure high availability. This is where AWS concepts become practical. 3. Senior cloud engineer. Now comes the next level. At this stage, you are no longer only following instructions. You start making technical decisions. Real-time responsibilities. Handle major production incidents. Optimize AWS costs. Improve security. Mentor junior engineers. Automate tasks using scripts. Imagine midnight production issue. Website is down during a big sale. Junior engineers panic. Senior cloud engineer stays calm and says, check logs first. Verify database connectivity. Rollback deployment. Shift traffic if needed. Experience becomes extremely valuable here. Because senior engineers know problems are normal in production. 4. Cloud architect. Now comes the highest level in many AWS careers. Cloud architect is like the master planner of cloud infrastructure. Instead of managing one server, they design complete systems. Real-time example. A company wants high availability, disaster recovery, multi-region setup, secure architecture, low cost, scalability for millions of users, cloud architect designs, VPC architecture, security strategy, load balancing, backup plans, scaling solutions, monitoring systems. Architects think about future growth, performance, security, reliability, business impact. At this stage, experience matters more than memorizing commands. 5. Learn concepts deeply. Now here is the biggest mistake many students make. They memorize definitions, commands, interview answers. But interviews today focus on real understanding. For example, instead of asking, "What is VPC?" interviewers ask, "Why do we use private subnet for databases?" This checks your practical understanding. So always learn why services are used, real-world scenarios, production problems, business impact. If concepts are strong, you can answer any interview question confidently. 6. Practice troubleshooting. This is one of the most important interview skills. Companies love engineers who can troubleshoot problems. Real-time interview example. Interviewer asks, "Website is slow. What will you check?" Strong answer. Check CPU and memory. Verify network latency. Review application logs. Check database performance. Validate load balancer health. Monitor CloudWatch metrics. This shows practical thinking. Cloud jobs are not about remembering theory only. They are about solving problems under pressure. 7. Focus on real-world scenarios. Now this is the secret to cracking AWS interviews. Always think like, how is this used in real companies? For example, instead of simply saying, 3 stores files, explain practical use, application backups, static website hosting, log storage, disaster recovery. Instead of saying, auto-scaling adds servers, explain real scenario. Traffic increases during sale events. AWS launches extra servers automatically. Interviewers love candidates who speak from practical perspective. Fun interview story ending. Imagine 2 candidates entering an AWS interview. First candidate says, "I memorized 500 interview questions." Second candidate says, "I understand how real production environments work." Now guess who gets selected more often? Companies want engineers who can think logically, troubleshoot calmly, understand business needs, handle real production issues. So your AWS career path should focus on concepts, hands-on practice, real scenarios, troubleshooting mindset. Because cloud engineering is not only about technology. It is about solving business problems using technology. And remember, every cloud architect was once a beginner confused by the AWS console.